of titration is iodate titration. Okay. Now, under iodate titration, so all of you remember that we have finished with KMNO4, we have finished with IOD and iodometry, dichromat and seriometry titration. Today, we are looking at iodate titration. This is simple, uh, a very small theory in this. So I want you to pay attention carefully so that you will be able to finish it in the lecture itself. So everyone keep your notebook and pen with you. So you have to write down the reactions and you have to write down the important points. Sorry, that this is not iodometry, it is iodate titration. So in iodate titration, your titrant is iodate, potassium iodate, that is KiO3. Now, your sample and analyte is reducing agent because your titrant is potassium iodate, which is a strong oxidizing agent in presence of acid. So it is important that whenever you are performing, whenever you are using titrant as potassium iodate, the reaction condition should be acidic, because if the reaction conditions are not acidic, the E0 is around 0.2. That it does not behave as a strong oxidizing agent. In presence of acid, the E0 is around 1.19. You can just check the reference. It is approximately 1.19. The value can be little here and there. Since it's a strong oxidizing agent, the analyte or sample is a reducing agent. Now, as I mentioned, it only behaves as a strong oxidizing agent in presence of an acid, and the acidic condition, acidic environment required is very strong acidic condition. It is not as like an other oxidizing agent. It does not, it cannot be utilized in a mildly acidic condition. It needs a very strongly acidic condition. So you cannot utilize any other indicator. You have to utilize organic solvent as an indicator. So chloroform or carbon tetrachloride can be used as an indicator. Now these are the solvent. So this is little interesting. This you have never seen, that a solvent which is a colorless solvent, which is not even miscible with the water, is utilized as a indicator. So this is what we are going to see today, how the chloroform or carbon tetrachloride, which is nothing but a solvent which is immiscible with the water, is behaving as an indicator. So pH, as I mentioned, is a strongly acidic. I always keep first slide as a summary slide, because when you look at this summary slide in the exam point of view, if you remember this slide, you will be able to write down a short note based on this summary slide. Now, principle. As I mentioned, potassium iodate is a powerful oxidizing agent, but the course of the reaction is governed by the condition under which it is employed. Condition means the reaction condition, whether it is acidic, and if acidic, how much acidic. That is going to decide how much powerful the potassium iodate is behaving as a strong oxidizing agent or not. Now, under suitable condition, it reacts quantitatively with both iodates and iodide and iodine. Now, the iodate titration can be performed in presence of alcohol, saturated organic acids, and many other kind of organic matter. So this is one of the advantage of the iodate titration. The presence of organic matter does not affect the reading. This is one of the advantage of iodate titration. So whenever you are going to use a iodate, potassium iodate as a titrant, if in your sample there is a presence of organic matter, the reading will not be hampered. Pay attention to the last statement now. Oxidation by iodate ion in strong HCl medium is going to proceed through several stages. What will happen at the beginning of the titration, that is in the initial stage, free iodine is liberated as more titrant is added. Then the oxidation proceed to the formation of ICl, and then the dark color solution gradually disappears. Now I do not expect you to understand this point right now. Let us look at the example and then you will understand the point very clearly. We are going to look at the assay of potassium iodide. So we are taking the example where assay of potassium iodide is performed by the titrant KiO3. So do not get confused between iodide, iodate, because they sound similar but they are not same. So we are talking about example is assay of potassium iodide. So in the flask, you have Ki, and in the burette you have KiO3. Now, what is the reaction? What is the principle is, whenever it is fixed that you have to use an strong acidic condition, but now we are looking at how much strong. If I use a 1 molar HCl, now when I use an 1 molar HCl, what happens? Everybody pay attention. This is a titrant, that is iodate. It will react with the analyte, that is iodide, that is in the flask, in presence of my acid, and it will form iodine. But problem is the reaction will stop over here only. It will generate iodine and reaction will stop here itself. So reaction is actually not going to completion. Okay. I assume everybody is understanding till here. We are looking at example of assay of potassium iodide by iodate, जहाँ पे Ki is in conical flask and potassium iodate is a titrant. And we are understanding, we are looking at कि जहाँ पे HCl is not added in a sufficient quantity, and if it is not added in a sufficient quantity, then the reaction will start with the formation of a iodine, but it will halt here itself. So what will happen? Let us not read what is written over here. Let us write down the further reaction. Ideally, what is supposed to happen is all of you write down the reaction with me. This iodate ion is supposed to take up the electron, and these electrons are coming from iodine. And then this Phi I plus and this chloride ion are going to convert into ICl. Because this is a redox reaction, you know there has to be an electron donor. There has to be an electron donor. So this iodine is going to give an electron and this is going to be accepted by the iodate ion. Okay. So this has to proceed like this, and then finally there will be a formation of ICl. So this is a complete reaction. But if this reaction will only go to completion if the HCl utilized is exceeding 4 molar. If you do not use the HCl more than 4 molar, the reaction will stop at the generation of iodine. Till here, everybody is clear?
Yes, ma'am.
Okay. So these reactions are extremely important if you are explaining the principle of iodate titration. Okay. So that is the reason for iodate to behave as a strong oxidizing agent, you need to provide an extremely strong pH condition. So I can say whenever you want to summarize, if I want to summarize this reaction, I can summarize this reaction as we are going to write we are going to learn the balancing of the reaction very soon. So this is the way I can summarize the reaction. In a nutshell, the summary of the slide is if I don't provide the enough concentration of hydrochloric H plus ion, the reaction will stop halfway till the generation of iodine and it will not go to completion. So I need to provide an H plus ion concentration sufficient. That is, I need to provide the H plus ion more than actually 2.5 molar, more than 2.5 molar, so that the reaction will go to the completion. And therefore, if you see the pH, so you can see the pH is always maintained extremely acidic and the molarity of the HCl used is between 2.5 to 9 molar, depending upon which assay you are doing. And hence, the HCl used for assays done with the iodate titration is usually concentrated HCl. What I want to show you now is, I want to visualize this, and that is the reason our MPharm student have done the experiment for you in our lab, because there is no YouTube video available for this. So what I want you to observe over here is, look at the starting, the color of the, this is KI assay. Okay, तो पहले तो आपको क्या देखना है, look at the color of the reaction. What is right now in the flask is potassium iodide, HCl and water. Potassium iodide is not yet added. Okay, so iodine generate हुआ है कि नहीं हुआ है, मुझे बोलो. Anybody? You have reaction written with you?
Yes, ma'am.
या तो मुझे बताओ, पहले फ्लास्क में आपने क्या लिया है, पोटेशियम आयोडाइड लिया है, उसके अंदर HCl डाला है और उसके अंदर पानी डाला है. तो राइट नाउ वेदर देयर इज अ जनरेशन ऑफ आयोडीन और नॉट?
No, ma'am.
Very good. So there is no generation of iodine. So look at the color right now. So it is very faint yellow because probably there is a iodide ion, and you have also added, if you can see over here, there are droplets inside the medium. Can you see the droplets at the center of the flask?
Yes, ma'am.
Yes, ma'am. Yes,
Yes, ma'am.
Those droplets are nothing but the separate chloroform layer. Those are the that is a 5 ml of chloroform added to the flask. Okay, so because you will add an indicator 5 ml chloroform, which will form a separate layer because it is immiscible with the water. Okay, so that is going to act as an indicator. How, I will explain you in a short. Okay, so now you can see as the titration proceed, you can see at the bottom there is a separate layer of a chloroform, the droplets which are formed separately. You can see the droplets very clearly, the two layers in the flask. So now they have started with the titration, and slowly you will see the color of the flask changing. Now see the iodine it started generating, and the flask is becoming more darker and darker because the iodine is being generated. So I'll just forward it and pause it. Now look at the color now. Why the color is dark now?
Iodation of iodine is taking place.
Yes, so iodine is generated. And can you see the second layer in the flask at the bottom?
Yes, ma'am.
Yes, ma'am.
It is very clear. Why? Because the chloroform का जो layer है, chloroform is a solvent. जो iodine जो generate हुआ है, the part of the iodine has got extracted into the chloroform layer. Okay, so then the chloroform is also in the iodine is also present in the chloroform layer. So you can see now the chloroform layer is become brown in color. Okay, so you have to proceed further for the titration. So they will proceed, they will keep on adding KiO3. You can see the color now. More and more amount of iodine generated, the colors of the solution become more and more darker. So dark that because of the iodine, you won't be able to, यहाँ से आपको video में, you won't be able to see the chloroform layer differently, but at the, when you will see with actual eyes, you will see the, at the bottom of the flask, the chloroform layer more darker. Then at the end of the titration, let us see what happened towards the end of the titration. Towards the end of the titration, iodine is being consumed by the KiO3. It is converted into ICl, and look at the color now. Can everybody see?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay.
Yes, ma'am.
Now tell me the color of the second layer. By any chance, are you able to see the second layer?
Yes, ma'am. Second layer is
Just a
yellow
minute.
in color and upper that it's
Yes.
reddish.
Yes. And the last now color of the second layer? Bubbles?
Somewhat colorless.
Yes, it is
Ma'am, it's
colorless.
colorless.
Yes, now it is colorless. So exactly that is I wanted to show you. Okay. So let us go back. So at the beginning, यहाँ पे आपके लिए photo है. You can see here the second layer was uh, uh, the chloroform layer, that is indicator. When it has and inside it the iodine trapped, it will look a brown color or a pink color. जब iodine का उसके अंदर concentration कम रहेगा तो वो pink color दिखेगा. And then at the end you can see the chloroform layer become completely colorless. So this is how you get the end point. The color changes during the titration of the iodate happens this way. And this is how exactly color changes, the reasons of the color changes, you can see, you can correlate with the reaction that you have written.